Hello everyone, welcome back to the math. So in this video, we are going to see how we can solve simultaneous equation. So the simultaneous equation will consist of one quadratic function and one linear function. This video is a part of the IGCSE AS and A-Level Pure Mathematics 1, but it's also open to those of you who are currently studying quadratics in any curriculum. So let's try to get on with the video. So like I said before, in this section, we will learn how to solve equations regarding one quadratic and one linear function. And there's only one technique that we need to use, and we already know about it, which is called substitution or elimination. Every variety of problem in this section will be centered on this technique. So before we begin, we need to see the difference between a simplified quadratic function and a general quadratic equation. It's called an equation because it's equal to a certain value, which in this case is equal to 0. But you don't really need to care too much about the difference because even if the equation looks like a bit complicated, the technique to solve this will still be either substitution or elimination. So let's try to see the following examples. So we need to solve the simultaneous equations. And to solve this, we need to remember to substitute x into y or substitute y into x. So in this case, I will try to use the linear equation since it is the easier equation out of the two. And I can get that x is equal to 2y minus 5. And after this, I can try to substitute this into the other equation, which is the more complex equation. So it's going to be like this. And after this, we can try to simplify it and find the roots. But before that, to know whether we are doing things right or not, by this point, there should only be one variable, either x or y. After we substitute it, we can try to simplify and then find the roots. So I'll try to move quickly with the simplification. And as you can see, the equation will be simplified into y squared minus 8y plus 7 equals to 0. So after this, we can try to factorize this, and we get y is equal to 1 or y equals to 7. But we are not done yet because we need to find the x. And to find the x, we can use the simpler equation, which is the linear equation. So we can try to input if y is equal to 1, that means x is equal to negative 3. And then if y is equal to 7, we know that x is equal to 9. So again, we need to use the linear equation to find the other variables since it is the easiest way. So to summarize, we know that there are two pairs of x and y that satisfy these simultaneous equations, which is minus 3, 1 and then 9, 7. And we also need to remember in a simultaneous equation, there can be two real solutions, one real solution, or no real solutions at all, meaning that all the roots are imaginary. The thing about simultaneous equation is that usually we try to make the problem such that it is a real life example or it is like a word problems. So this is one of the examples. The sum of the perimeters of the two squares is 50 centimeter and the sum of the areas is 93.25 centimeters squared. And we need to find the side length of each square. So let's try to illustrate this. So we have two squares, a times a and then b times b. And then we have to gather all the available information first. The first one, the sum of the perimeter is 50 centimeter and we need to make this into an equation. So the equation can be 4a plus 4b equals to 50. The next one, the sum of the area is 93.25 and we can make this into an equation. A squared plus b squared equals to 93.25. So after getting the equations, we can try to simplify it, especially the first one, yeah? So it's going to be 2a plus 2b equals to 25. And then we can try to change the form. We can try to change it such that a equals to 25 minus 2b over 2. The reason why I need to do this is because I want to substitute the a into b. So we need to substitute this into the other equation. We can plug in the a in the more complex equation so that it becomes like this. And after that, we can try to simplify and find the roots. After getting this expression, we can try to simplify it, and in the end, we get this quadratic equation, 2b squared minus 25b plus 63, and then we can try to factorize it. in the end, we got b equals to 9 or b equals to 3.5. But we are not done yet. We need to find a. So after getting the b values, we can try to find the a by inputting it into the first equation. Again, since it is a lot easier. So if b is equal to 9, we got that a is equal to 3.5, and then if b is equal to 3.5, we get a is equal to 9. And as you can see, it results in the exact same pair. So there should only be one answer. To conclude this, we know that the side length of the squares will be 3.5 centimeter and 9 centimeter. But here's the thing though. How do we know whether the answer is true or not? If we have any doubt, we can try to check the answer using the more complex equation. Again, this is not mandatory, it's only optional, only if you are in doubt. If you are confident in your answer, you can just try to skip this step. How can we check whether the answer is correct or not? We can try to input it to the more complex equation. So let's just say that a is 3.5 and b is 9. Again, because we know that we can interchange this. So if we try to add this, we got 93.25. Since the sum on the right-hand side is equal to 93.25, so it goes back to the problem statement, we know that our answer is correct. So this is the next example that I want to show you guys. This is actually a very common problem. So a cylinder has an area of 24 pi centimeters squared and the height is 10 centimeters longer than the radius. So what is the possible value of the radius and the height? Before we begin, we need to illustrate the cylinder. So this is going to be the cylinder with a radius r and a height h. After that, we need to gather all the available information. The first one, we know that the cylinder has an area of 24 pi. And then we want to make this into an equation. So we need to remember the formula for the cylinder's area, which is 2 pi r times r plus h is equal to 24 pi. The next information that we can get is that the height is 10 centimeters longer than the radius. So h is equal to r plus 10. So we can try to summarize the equations that we have, which is this one. So these are the equations that we can get from the previous slide, and we can try to simplify the first equation. Yeah? So it becomes r times r plus h is equal to 12. And after this, we can try to substitute the h into the first equation, since the first equation is a much more complex one, right? So it's going to be like this, r times bracket r plus 10, because h is equal to r plus 10. And then this is equal to 12. After this, we can try to simplify it and find the roots. So simplifying it, we get a good quadratic equation, 2r squared plus 10r minus 12 equals to 0. And then you can also try to simplify this by dividing it with 2. But I'll try to skip that step, and we got that r is equal to 1 or r is equal to negative 6. Now in this case, we need to remember to always leave out any impossible answers, because we know that technically, negative radius is impossible, okay? So we got from the previous slide that r is equal to 1, but we're not done yet. We need to find the height of the cylinder. So the height of the cylinder should be 11. So to conclude this, we know that the radius and the height of the cylinder is 1 centimeter and 11 centimeter. Again, if you have any doubt on your workings, you can try to check it using the more complex equation. Again, it's optional. Now for the next one, it's actually a much more complex example that I want to show you guys. So Andy wants to construct a rectangular football field, which is denoted as the green area. It is known that the field's length is twice of the width. He also wants to make a running track, which is denoted as the gray area with a width of 2 cm like the figure below. If the total area, which means the football field and the running track combined, is 128 meters squared, what is the area of the football field? So again, we can try to see the illustration where the green part is the football field and the gray part is the running track. So we can try to denote its length and its width first. Let's just say that the length of the football field is L and the width of the football field is W. That means we know that the total length should be L plus 4 and the total width should be W plus 2. Okay? After this, we need to gather all the available information. We know that the field's length is twice of the width. Again, it's the football fields, yeah, not the total. So the football field's length is twice of its width. So L is equal to 2 times W. And then the total area of everything is 128 meters squared. Yeah, this one should be meters squared. So we can try to write it as L plus 4 times W plus 2 is equal to 128. So we got our two equations. From the equations that we got previously, we can now try to make some substitutions. We can try to substitute L with 2 times W. So it's going to be like this. After that, we can try to simplify and find its roots. So simplifying it will get us this quadratic equation, and then we can solve for W. So W can be equal to 6 or minus 10. Again, we need to leave out any impossible answers. We know that negative width is impossible, okay? So the eligible answer is only W is equal to 6. After finding the width, we need to remember that we need to find the length. So to find the length, we can just use the first equation. So L is equal to 12. And we are also not done yet because we need to find the area of the football field. And again, if you have any doubt, you can try to check the answers first using the more complex equation. Again, it's optional. So to find the area, we just have to use the formula, which is length times width, and then we just have to plug in the values of the length and width. It's going to be 72 meters squared. Yeah, this one is a typo. So the area of the football field is 72 meters squared, not centimeter, yeah? Okay, so these are the exercises that I've prepared so that you can try to solve these simultaneous equations so that you can get used to it. And then I also prepared several problems regarding the word problem so that you can try to infer the equations from the sentence that you have here, because it's actually the main challenge that student gets sometimes when working on these types of questions. So you need to translate these narratives into the equations and then solve for the equations. Okay, so that's it for this video. In this video, we learned about simultaneous equations. What do you think about this video? Please leave a comment if you have any questions that you want to ask, and don't forget to leave a like and subscribe. So I'll see you on the next video. Bye-bye.